Hello, SLOconf. My name is Xuereb. I'm a self-site reliability engineer at GitLab, and I wanted to talk to you today about so many SLOs, so many alerts. So at GitLab, we're already using SLIs, and we alert when we start burning through our error budget, where we use multi-window burnouts. And we alert on the 1 hour window and also the 6 hour window. Each service has multiple SLIs, either on a zonal level, on a regional level, and also on multiple components that the service might be made out of. And in the past, we were alerting the on-call we were paging the on-call for every alert that was firing, which is a really good setup overall. It was really mature. I felt it was really mature. And we were quite happy with it because we were alerting the on-call on symptom-based alerts rather than cause-based alerts. But we had a few problems in our setup. One of them is when there is a service-wide degradation. As I mentioned, we have SLIs for regional specific alert SLIs and zonals and also components. So if there's a whole service-wide degradation, we see multiple alerts firing in one go. So an example here, we can see in 10 minutes, there were 10 alerts that fired because the whole service was down. And that means the on-call got paged 10 times in 10 minutes, which is not a really good experience for the on-call when they're trying to solve a problem, right? They get paged, it's already a stressful situation because they got paged and they're keep getting paged for the same issue multiple times and they keep getting distracted. This is even worse when there's a whole site-wide outage. So we're a Ruby on Rails monolith mostly, and we heavily depend on the database. So if the database is down, there's a high chance most of the application is down, like the API, for example, service and the web service. So a lot of SLIs end up firing in this case. And we can see here one on-call person got paged around 70 times within a span of 10 minutes because the whole site was down. And it kind of feels like this. The whole site is down, you're trying to fix the problem, but you keep getting distracted because pages are firing. You need to, it is kind of your nature to go look at the page to see if it is a signal or mostly noise, but most of the time it's noise. It's already a known issue, right? Like we know that the whole site is down, so we need to focus on that. So we had two problems to fix here. When there is a service-wide degradation and when there are cascading failures. So the whole database is down. We don't need to focus on the API or the web just because we need to bring the database up again, for example. So we had multiple ways to do this. One of the first thing we did is entertain ourselves to see if we can implement our own solutions for these. We quickly scrapped that idea because we looked at, for example, PagerDuty's uppering, which is what we use to page the on-call. It did have some really nice features, but required us to update our license a little bit and also do some major refactoring of how we handle PagerDuty. So it was quite a big cost increase, both from a dollar perspective and the maintainability perspective. And then we also looked at Prometheus. We already are using Prometheus for all of our metrics gathering, alerting, and routing. So we already depend on Prometheus quite heavily. So it felt quite natural to use Prometheus's feature. So tackling the first problem, service-wide degradation. So one idea was like, let's group by service, right? So if a service is degraded, we should group all of the alerts into one go, right? And luckily, Alertmanager, which is part of Prometheus, has this feature already called grouping. And basically, you can group by a specific set of labels. All of our alerts had the type label, which is the name of the service, and the environment it's in. So we could group all these together into a single alert. And we can see an example here where we see 3 alerts, and we're grouping them by the type label and the environment label, and they end up being one single alert. And that is just a matter of updating Alertmanager configuration with just the group by keyword and specifying the labels that you want. There are some other configuration fields that you can add, like the wait interval, like how long it's going to wait before it fires the alert. So make sure you group as much as possible. But we ended up going with the default values on that just because it felt the best values. So this was a bit of a mental shift for us. Before, as I said, we used to be 1 alert equals 1 page, right? And we can see here, each of them is like each of them in a separate page, a separate alert. And they have, like, the on-call has to triage each one of them to make sure, oh, are they of the same service and whatnot. So we changed this a little bit to be page once on a service, so a service pages rather than an alert pages. And then you get a list of all the alerts that are firing for that service. And this kind of cleaned up a lot of our alerts. So the service degradation, instead of getting 10 alerts in 10 minutes, you get 1 alert, and then just a list of them. Now that we're alerting by service, we could implement a service dependency, which will tackle our second problem we had about cascading failures. So for implementing service dependencies, we also ended up using another Alertmanager feature called Inhibition. And the way this works is basically you tell it, hey, this alert will take priority over another alert. And if the second alert that doesn't take priority is firing, it will not alert or page the on-call. And this is how we configure it. So we can see the alert at the top is of component Rails primary SQL and type Patroni, and the one at the bottom is component load balancer type API. And in the middle, we can see our Alertmanager configuration, where we're saying the source match. So we're matching via labels using component Rails primary type Patroni and the target match load balancer API. So if the type Patroni alert is firing, it will page the on-call. And if we have this inhibition rule configured, and this alert type API fires, it will target match it, and it will end up being inhibited because we have this source match here. So we had to write this configuration, but we didn't want to write it by hand, especially because most people didn't, like most SREs didn't want to know, like didn't need to know that we're using inhibition rules behind the scenes. And we're already defining all of our SLIs via a single JSON file. So each service has a JSON file, and they specify the error rate, the fdex ratio, the fdex, and like which metrics to look at, and so on. So we added a new keyword here called depends on. And here you just specify the component that this SLI depends on and the type. So here we're saying the load balancer depends on the Patroni database, right? So if the Patroni database is down and it's it's burning through the error rate, there's a high chance that the load balancer will also start returning a bunch of errors and will also end up firing a bunch of alerts, right? So that's why we implemented depends on. And then we could also, with this JSON file, we also implemented some validation logic to make sure, hey, does the service look correct? Does it exist? Does the component exist? There's no cyclical dependencies and things like that. Because inhibition rules are a bit dangerous because sometimes you're silencing an alert and you might not want that. So that's why we implemented it in JSON, so we can implement some validation logic. And that depends on right here, ended up creating generating all this Alertmanager configuration for us. And then we just push it to our Alertmanager deployment. So how did we do? After we rolled out alert grouping and inhibition rule, we saw a considerable decrease on the number of pages. We can see here the number of pages we get on a weekly basis. And as soon as we rolled it out, we see a decrease, and it was beneath our target. So it was quite a good way forward. The on-call got a single alert. They could focus on that. And we've seen it work quite well. Like, for example, we had one event after we rolled this out where the database was violating the SLO. And instead of getting like those 70 pages that I showed in the beginning, the on-call only got around 5 pages for the database, and then some black box and ping them alerts as well. So that was a good project overall. Thank you so much. You could look at the slides here if you're interested, and if you were interested in a written format for this talk, you can look at the blog post there. Thank you, and enjoy SLOconf.